Let's see some more problem of static equilibrium of a rigid body. Here I am showing a problem and a picture. In the picture we can see there is a bar ABC where the bar is bent beyond this point and having an angle 40 degree from the horizontal direction. Joint C is a pin joint and joint A is having a roller kind of joint, or we can say that it's a point contact, and the roller is also placed on an inclined surface which is also having a 40 degree angle. The point of contact is 96 mm above from the ground. Point B is having a pulley and the pulley having a weight of 18 kilogram. The diameter of the pulley is 240 mm and this distance is given as 240 and the 240. Now let's read the question that 18 kilogram pulley is attached to a bar ABC at point B. The cable running our pulley has a tension of 600 Newton. Find reaction at A and C. So we have to find the reaction at point A and at point C. So now our first job, whenever we are having a problem of rigid body dynamics, rigid body static equilibrium, first we have to make the free body diagram of our system, and we have to see that how many free body diagrams we can make in this system. So we know there are two major component in our system. One is a bar, the bar A, B and C. The second component is a pulley which is connected at point B, and let me tell you that what type of connection a pulley is having with the bar. So we can see that when we have a pulley kind of joint, basically what we have, suppose I will remove this joint, this B joint. I am just opening the B joint. So what I will observe that this is my bar A, B and C, and there will be a pulley, and the pulley and the bar will be connected through a pin. So the pulley and the bar is also having a pin joint. So now suppose I want to make free body diagram of pulley. So in the case of pulley, I will consider the tension of the pulley as well as the weight of the pulley, and there will be a reaction between the pulley and the pin, and that reaction can be defined with the help of two forces, because conventionally what we do whenever we are having a pin joint, we remove the pin joint and we consider two reactions which are perpendicular to each other. So in my case, if I will consider there will be a downward reaction because of this pin, that is By, and a leftward reaction because of the pin, this is Bx. So as I know that these two are the counterpart, so if I am making the reaction downward and leftward at this point, I have to make equal and opposite reaction at this point, and that reaction ultimately will transfer to the point B. So now let's draw the free body diagram of our pulley as well as our bar. So these are the free body diagram of my pulley and my bar. We can see here that when I am removing the pulley, I am considering there will be two tension on the pulley, the weight of the pulley and the two reaction, and I am assuming that this bar basically applying a force on the pulley, and the direction of these two forces are leftward and upward. At the same time, I am making the free body diagram of the bar where point A, the point A is having a connection with an inclined surface, so the reaction will be normal to the surface. So I am making a reaction, I am considering it reaction A, and the angle of this direction, this force will be 50 degree from the horizontal Y, because this is a 90 degree angle, and when I will complete this triangle, this is 40 degree, so this will be a 50 degree angle. Point B is the point B is the connection between the pulley and the bar. So as I have considered the force Bx and By on the pulley in left and upward direction, the force at point B on the bar will be equal and opposite to these two forces. So I am considering that it will be leftward and downward. Since point C is a pin joint, I am assuming two forces. One is the left one and another one is the upward. As I don't know what is the exact direction of the forces at point C, I can take any direction. When I will calculate the these reactions, if my answer is negative, that means I have considered the wrong direction and I have to change my direction. So now if once the second job, as you have the free body diagram, the next job is to just write the equation of equilibrium. So we have to balance the forces as well as we have to balance the moment. Now let's see, these are the equation of my free body diagram. First, in this case, I am considering the balance of vertical forces. So By is the vertical force. Let's assume that upward is the positive direction and rightward is also a positive direction. So By is acting in the upward direction, and both 18g, this is basically, if I am assuming that the g is 10 meter per second square, so my gravitational force will act in the downward direction, that will be balanced by the By, as well as the 600 is also acting in the downward direction. So total downward force and total upward force will be balanced, and which will give the By value is 780 Newton. If I will balance the horizontal forces, there are two horizontal forces, 600 and Bx, and this Bx is also acting in the right side and 600 is also acting in the right side. So these two will be 0 and my Bx is coming 600. What is this significance of this negative value? The negative value indicates that I have assumed a direction of the reaction towards the right, but actually in my system this force is acting towards the left side. So now I am not going to change the direction, only I have understood that my answer is negative, so the direction, actual direction is leftward. But as I have already made a counter direction here, so I am not going to change my direction, but I know that here also the amplitude of Bx will be considered as minus 600. Now if I will write the equation for the forces and moment for this free body diagram, first let's write the equation for the horizontal force balance. So in my case, how many horizontal forces? One horizontal force of Bx, one horizontal force because of the Cx, and one horizontal force will be a component of this force. If I'll see that this is my force, which is A, so one of the component will be in this direction, this is xx, and one of the component will be in the vertical direction. So if I will balance my forces, that's A cos 50, this is basically A cos 50, minus Bx and minus Cx, because here also I am assuming that the rightward is the positive direction and upward is the positive direction. So my horizontal force balance will give this equation. When I will balance the vertical forces, there are three vertical forces, Cy, By, and a vertical component of the reaction A. So A sine 50, because the vertical component will be A sine 50, then I am having By, which is acting in the downward direction. As I have assumed By upward here, I am assuming By downward here. So negative By and Cy. When now the third equation I can write using the moment. I have a choice that whether I can consider the net moment 0 here, 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 anywhere on a rigid body. If the body is in equilibrium, that means the moment balance at any point of the body will be 0. But I have to choose a point with some wisdom, that if I will take a point unknown balancing point here, I am going to take the moment of this point as well as this point. Sometimes what happens that there are more unknowns, so what we do, we take a point where the number of unknowns are more, so that if I will take the point C, that means the effect of this Cx and Cy will gone, because the moment of this force and this force will be 0 is this point. We'll see this in the next problem. So now in this case I am taking a moment at point C. If I am taking a moment at point C, that means there will be number of forces which will have a moment at this point. One is the By force. The By will having a force, and this is the perpendicular distance for the By. If I will see the effect of Bx, the effect of Bx will be 0, because the line of action of Bx is passing from this point. Then there are two forces. One force is Ax here and another force is Ay here. So the effect of Ax and Ay will also be there. So I am writing this equation that A cos 50 is my horizontal force, which is having the line of action of Ax is this way. So the distance between the point of action and my force, perpendicular distance, is 96. So I am writing A cos 50 into 96, and the effect of this force is basically clockwise. because I know that if I am having a body like that and the body is pinned at this point, and if I am applying a force here, the net effect of this force will try to rotate the body in the clockwise direction because the force is above the point of interest. So this moment of this force, which A cos 50, will be positive. Now the vertical force, this is A sin 50, and this distance between A cos 50 and the point C is basically 250 plus 250, so this is 480, and the effect of this is also clockwise because the force is acting in the upward direction. Now the third force is my By. The By is acting at 240 mm away, so the minus By into 240, because By is acting in the downward direction, so effect of By will be counterclockwise. If you will see my previous video, there I have explained that how to find the sense of this movement, whether it will be a clockwise or a negative anti-clockwise. So when I will write these three equation and I will solve this is three equation, from this equation I will get that A will be 435.94 Newton, and when I know the A value, if I will put the A value here, I will get the value of Cx, as I will get the value of Cy. So when I will put this value back to my equations, here I am getting the Cx is 880 and Cy is coming out 446 Newton. So now finally I am having the value of A as well as Cx and Cy. Let's see a second problem which is relatively difficult and very important, because in this problem we are having a system of bar ABC, bar CDE, bar BD, a pulley which is at point F, which is at the center of this BD, and a wire. So the statement says that a weight of 6 kilonewton hangs from cable which passes our pulley of radius 0.4 meter. So this pulley is having a radius 0.4 meter. Find the reaction at point D and B, and the pulley and the bars are weightless. So weight of the pulley is 0 as well as the bar doesn't have any weight. The only force which is acting in the system is because of this W. As I said that if we are having a problem of rigid body, the first job is to make the free body diagram. In my case there are number of bars, so first I have to see that how many free body diagrams I can make from this system. So here I can make number of free body diagrams. Let's see that how many free body diagrams are there which we can make, and we can use those free body diagrams to get the unknowns. The first free body diagram generally we make by removing the joints. And you can see here that the joint A is showing as a pin joint. So this is my pin joint, and here I can see that the system showing some roller kind of thing, means this is my roller joint. Now first free body diagram could be only I am removing the two joints, so remaining will be same. Here will be my here will be my pulley, and this is my downward force W. So here what I did, I have only removed the support A and E. So I know that support A is a pin joint, so there will be two reaction. Let this is AY and AX. I don't know whether it will be upward or rightward, but as these are the unknowns, I am taking these two values randomly. When I will solve the problem, I will get the actual direction. Since E is a roller joint, so the force will act in the upward direction. So this would be my EY. Nothing else, because I am not removing any other joint, only I have removed joint A and joint C. So my free body in my free body diagram, these two joints will be replaced with some forces. So this is my first free body diagram. Now second free body diagram, pulley itself. So suppose this is my pulley. This is my pulley having a load W here, another load W here. This is my center of the pulley. So let's assume the two forces which are coming because of this rod on the pulley, and the direction of these two forces, this is my Fx and this is my Fy. This is my second free body diagram. Third free body diagram would be, let's remove the pulley only and take all other things. So effect of pulley will basically come on the bar because of these two reactions. So again, this is my 2 bar. Since I am not doing anything else, only I am removing the pulley, so this would be my bar here, and there will be two forces in addition to these two forces. One is the AY, one is the AX, one is the EY. Another two forces which will be equal and opposite of these two forces, because pulley, this is point F, here also this is point F. These are the two F point in which are the counter point. One is on the bar BD and one is on the pulley. So if I am assuming these two forces, I have assumed, I was not aware what would be the direction of these two forces. I have assumed these two forces randomly, but when I am making the next free body diagram, where again I am making the F point, here I cannot take a random direction. I have to take the direction which will be opposite to these two forces. So my Fx will be in this way and my Fy will be in the downward direction. What else I am having? I am having a force W because of this point, because I am removing the pulley. So this is having a tension W here also. So I have to make another force which will be in this way. This is my W. This is my third free body diagram. Now if I want to make further more free body diagram, suppose I want to make another free body diagram of this bar. Okay, one more free body diagram would be, I am just removing the bar BD. So these are my forces. This is AY, this is AX, this will be my EY. I have removed the bar BD, so one force W will be here. Now I am not having any force because of the pulley, but reaction of the at point B and D will take care of all the forces. I don't know the direction of BX. I am assuming two directions. One is BX and BY. Similarly, I am having force DY and this is my DX. First time I am making point B and D, so I am free to take any direction of point B and D, because these are two unknowns. Now the next free body diagram would be the bar BD only. If I am making the free body diagram of bar BD alone, this is my point B and this is my point D. So I know that I have already assumed that the direction of reaction at this point, here also B point, this is the counter point which is on the other bar. So I have to take the reaction opposite what I have considered there. So this will be my BX and BY. Here also I will be having, so this will be my DX and the downward DY and the pulley reaction. Now again I know that these are the reaction I have considered here. So I am going to take the same reaction. Why? Because this bar is same here and here. The only counterpoint on the bar is on the pulley. So whatever direction I have considered on the pulley, the equal and opposite direction will be here. But I don't consider opposite to this point, because this is the same bar. I am just removing these 2 points and this force will be as it is what I had here. So my two forces will be again, one is the Fy, one is the Fx. This is the next free body diagram. What else we can have? We can even make the individual bar. Suppose this is my individual bar of A, B and C. So now I am having two forces. Again I will be having this AY in the upward direction and AX in the horizontal direction. B is the same point. This is not a counterpoint. Counterpoint is this one. B is the same point here. So again the two forces, which is BX and BY. Again I am having a C point and I am free to make any direction. So I am assuming, let's see, this is CX and CY. What would be the next free body diagram? The next free body diagram of this bar, which is just opposite to this. So let's make the next free body diagram here so that we can compare these 2 points. Now I know that I have assumed the C point and this is the counter C point, so my reaction will be equal and opposite to this. So this is my CX and this one will be my CY. Remaining, this is my force W, which is coming because of this tension in the wire. Then I am having force D already assumed here. This is the same bar I am making. This is the counterpoint and this is the same bar. So my DX and DY. And I am having a point here which is E. So this is my EY. So we can see that how many free body diagrams we have for this particular problem. This was our problem and we can make approximately 1, 2, 3, 4, 5, 6 and 7 free body diagrams. Is that mean that we have to use all the free body diagram? No. It is up to us that which free body diagram we should use so that we solve or get the unknowns in a less computation, mathematical computation. So now I have just explained you that if you are having a problem, initially you should know that how many free body diagrams you can extract from your problem. 1, 2, 3, 4, 5, 6, 7, and now I will solve my problem. So conventionally what we do, generally we start our problem with just removing the support. So I will start my first, this is suppose my first free body diagram where I have removed only these two ends. So this is my first free body diagram, and this is my second free body diagram where I am taking the forces only on the pulley, and here I am assuming the direction of my horizontal force, horizontal reaction and the vertical reaction. And these are the reaction because of I have removed joint A and E. Let me tell you that in the details of the free body diagram, I have taken the direction as randomly. Here I am taking the direction. May be possible that whatever direction I am showing in this picture is not same as I have shown in earlier when I made the free body diagram. It doesn't matter. When you will start the problem, you have to take a direction and then you have to follow the direction when you throughout the problem when you calculate the all the forces. So now let's start that this is my first free body diagram and this is my second free body diagram. When I will write the equation for my first free body diagram, I know that this is 2, again this is 2, and this is 1.5, and again this is 1.5. Let me tell you, you should be very clear that this pulley is fixed at point B, but this wire is not attached with this pulley. Only this wire is attached to this diagram, and the wire which is coming from the pulley is independent from bar BD. So now in this free body diagram, if I will balance the forces, I am going to balance the horizontal forces. So horizontal forces, if I will see, there is only one horizontal force. We cannot take any force here because this is connected, this is not free. We don't have the joint. This is not a free point. As it is not a free point, I am not going to consider any force here. The only force which I am going to take is coming because of the load W. And now if I will balance the horizontal forces, there is only one horizontal force, so I know that AX will be 0. If I will balance the vertical forces, there are 3 vertical forces, AY, EY and W. So my AY and EY is acting in the upward direction, W is acting in the downward direction, so these two forces will be balanced by W. Now when I am doing the moment balance, I am free to take moment at any point, here, because now in this case only these are the points. Other things, the body is considered as a rigid body. There are only 1, 2, 3 and 4 forces. So I am free to take moment at any point, but I am taking moment at point A so that these effect of these two unknown will be 0. Only I will be having the effect of this force EY and W. So I know that the radius of the pulley is 0.4. So the effective distance of force W with respect to point A is 1.6, because this is 2 and I am removing this 0.4, so this is 1.6. so this is like when I am taking the equation of moment at point A, my equation will be EY into 4, and as I know that EY is acting in the upward direction, so the effect of EY at this point will be counterclockwise direction. If you are still confused, you can consider that this is the diagram of the system and here is the point and I am applying a force here. If I will apply a force here, the whole system will try to move in the counterclockwise direction. Please remember that when you are taking the effect of a force in terms of movement, forget all the forces, just take a single force which is of your interest and take your point and try to understand the direction of couple at the point of interest. This is my point of interest A, this is my force which is acting in the upward direction. So ultimately the effect of EY will be EY into 4, but its sense is counterclockwise. So this, because it is counterclockwise and I am assuming that the counterclockwise will be negative and clockwise will be positive. This is my convention which I considered. If you want to take opposite, it is okay, because ultimately the equation will be same, only the sign will be interchanged. So my Ey into 4, this is Ey into 4, the second force will be W into 1.6, as W is acting in the downward, its effect will be clockwise. So this would be my equation. When I will solve this equation, I will get that Ey will be 2.4, and when I will put my Ey into this equation, I will get that Ay will be 3.6. Now let's see the second free body diagram, which is the free body diagram of pulley. I have removed the pulley from this point, so I am free to take any reaction at this point. I have assumed that the horizontal reaction is leftward and vertical reaction is upward. When I will write the equation, I know that the pulley doesn't have any weight, so weight of the pulley is 0. So Fx will be balanced by W and Fy will be balanced by W, so my Fx and Fy will come W. Now let's again check that what would be the next free body diagram. I have a choice number of free body diagrams. I can take this one, this one, this one, anyone. So what I will do, I will take a free body diagram. This would be my next free body diagram. So suppose this is my free body diagram. This is my next free body diagram. I'm showing it so that we can compare that this was the total bar and this is my free body diagram. I have just removed this bar and the pulley. So now I am having a point force here, which will be equal to the W and the forces because of the reaction at point B and at point D. So now this is my free body diagram. Ay I have calculated, that is 3.6. My Ax force is 0. This Ey is 2.4 in the upward direction. I have assumed forces Bx and By in this way, as similarly Dx and Dy in this way, and now as I know, now I have the free body diagram, I have to write the equation for the force balance as well as the moment balance. Now again the question arises at which point we have to take the moment balance. I have the choice to take moment at C, B, A, E, D or anywhere on the body, but I am going to take the moment at point B. Why? Because when I will take the moment at point B, at least the effect of point Bx and By will gone, and I will be having the unknowns Dx and Dy. So now if I will write the equation at point B, I am having this force Dx. Again the Dx is passing through point B, so effect of Dx will gone. So then I am having a force Dy. Dy, line of action of the Dy is going in this way, and the distance between the B and the D is 2, because when we will see here, this is similar triangle, this is 4, so this will be 2, and the half of this will be 2. Similarly this half distance will be 2, and the vertical distance will be 1.10 and 1.5. so my equation will be Dy into 2. Then this W, the line of action is W is passing from here, then this distance is defined. The Dy is having, because the radius of the pulley is 0.4, so this top distance will be 0.4. Then I am having force Ay. Ay is acting at this point, and the point B is having a distance 1 from Ay. Ay is direction, line of action of Ay is this one, so perpendicular distance of Ay will be 1. Please understand that this is not my perpendicular distance, even this is not my perpendicular distance. As the Ay force, line of action of the Ay is going in this way, this is my perpendicular distance, and which is 1. So Ay into 1, and then Ey, line of action of the Ey is this way, and the perpendicular distance of the Ey from point B is defined is 3. So now this is my equation. I have not mentioned any sign. Let's make the sign. What will be the sign because of the force Dx? No, because Dx is passing from point B. Then Dy is acting upward, so the whole system will try to rotate in the counterclockwise direction, so this will be my negative sign. Then the second will be Ey. Ey is also acting in the upward, so Ey will also try to rotate the system in the counterclockwise, so this is negative. My Ay is acting upward, but it is on the left side of the point, so it will be having a clockwise effect, so it will be my positive, as well as W is acting in this way, so it will also try to rotate the system in the counterclockwise direction. So finally I am having an equation where 3 negative sign and 1 positive sign. These 3 are counterclockwise movement, and movement for because of Ay is clockwise. When I will solve this equation, because all other values are known to me, I am getting that Dy is minus 3. Again this minus sign. Minus sign means that Dy is actually will be in the downward direction, but as I have considered the Dy in the upward direction, I'll keep this direction same throughout my problem, but I'll put the amplitude of dy negative whenever I will have to use the value of dy. Now when I'll do the force balance. There are vertical force balance there will be 4 vertical forces, 1, 2, 3 and 4. Out of these 4 forces only by is unknown. So when I will balance the vertical force equation, I am getting that by is -3. I am not interested here to find the forces horizontal force balance, because, or even if I will do the horizontal force balance, my equation will be if I will balance the horizontal forces, the equation, how many horizontal forces? One is bx, which is positive, then dx, which is negative, and this w, which will be 0. As I don't know the bx and dx, I am not able to get any answer from this free body diagram now, so I have to move to the next free body diagram. Now my next free body diagram will be, let the individual bar ABC. I have different choices, but I am taking this because this will give me result quickly. So when I will take the free body diagram of bar ABC, this is my point A, this is my point B. Please understand that in the previous case also I have taken the direction BX this way, and this is the same point. I am not taking its counterpoint, which is on this bar BD. So this is the same point on the same bar, so it will be, I have just removed this portion from my system. So I am going to take forces at point C, remaining all the forces will remain same. So this is my next free body diagram, where I know the AY value, I know the BY value, unknowns are BX, CX and CY, and I have to find the value of these 3 unknowns. Now again, I know that if I'll take the moment at point C, the effect of force CX and CY will go away. Only I will be having an unknown BX, and that will be easy to get the value of BX. So let's take the moment at point C. Now if I'll balance the force at point C, I am having force AY, which is passing this way, and the line of action is having a value distance 2. So AY into 2, and the sense of the AY will be clockwise. This will be 2 distance, so AY into 2 will be clockwise, so it will be plus. Then I am having a force BY, as I have shown the direction upward, and I know that actually it is downward, but I am not going to change the direction because I am going to take the value as negative. So my BY effect will be clockwise, so I'll put that this is also positive, but later on when I will put the value negative, its effect will automatically come. Now I am having the force BX, which is having a distance 1.5 from point C. This is the perpendicular distance. So BX into 1.5, and again it is having an effect which is counterclockwise direction, so sign will be negative. Now this is my equation of moment balance at point C for this diagram, and when I will solve it, I will get that the BX is coming out 2.8. What the next free body diagram? Now I know the forces at B, I know the forces at A, I know the forces at F, and I don't know the forces at D. So the easy way is to make the free body diagram of this bar BFD. Now I know that this would be direction of force Bx and By, but the magnitude will be negative because earlier I have taken the Bx right and upward, so it is the counter B point, so the downward and the leftward. This is that counterpoint for the pulley. If you will recall the free body diagram of pulley, I have taken the free direction of this force rightward and upward. So in the counterpoint, this is the leftward and upward, so this will be rightward and downward. So when I will solve the free body diagram of this bar, and I know that the force Vy is -3, dy is -3, dx I don't know, bx is already 2.8 I have calculated. So and the fx and fy is known to me. Here also you can check that we know that the fy is w, and it is balanced by these two reactions. That means we did correctly. So now if I will balance the horizontal forces in this diagram, I am getting the dx is -3. So now I know all the reactions at point B and at point D. The reaction at Bx is coming out 2.8, By is coming out -3. That means it is acting in the downward direction. So it is downward. This is correct, plus. So the direction of the Bx will be towards this side, and I am getting dx -3, and I have assumed the direction of dx is rightward. That means actually the dx is acting in the leftward direction, and my dy is -3, so dy is -3, that means actually the dy is acting in the upward direction. So I have the reaction at point B, which is rightward and downward, and direct reaction at D is the leftward and the downward. Thank you.